We're actually going to continue on talking about probability distributions, but we're actually going to continue with talking about a specific type of probability distribution called the binomial probability distribution. And if you see right here, you have to meet these 4 requirements for it to be considered a binomial distribution. First, your procedure has to have a fixed number of trials, which generally they'll tell you, out of 8 trials, or if they're, you're having an experiment with 8 P's or 8 births, something like that, that's your fixed number of trials. And the trials also have to be independent of one another, so, the outcome of one should not affect the subsequent ones. Now, this is the big thing I look for whenever I think about binomial. Bi means 2. Each trial must have outcomes classified into 2 categories. And we normally call those success and failure by default. But success and failure don't necessarily mean like, good thing, bad thing kind of, idea. It's just basically what you're looking for will be your success. So if you're doing an experiment where you're looking for a probability of having a girl or girl babies, that would be your success. And then failure would be having a boy. So it's not necessarily a good or bad thing. It's just how we talk about these binomial experiments. And then the probability of success has to be the same in all trials. So usually, take for instance, the trial of having births. Usually about 50% chance to have a boy or girl. That's not going to change going to your next child, your third child, your fourth child, and so on. It's going to be the same chance to have a boy in every one of those trials, or a girl in every one of those trials. So usually that doesn't change unless you change something significant with your experiment. So look at this example below, right here, where we have giving Lipitor to patients, and it says part A, we have 863 subjects with Lipitor, and we record whether they yes got a headache or no they didn't. So I guess we're asking them, did they have a headache when they used Lipitor? Of course, we do have a fixed number of trials, so you can see just from this experiment, there are 863 trials, 863 people were asking, so we do have a fixed number of trials. Are the trials independent? Well, each person, whether they got a headache or not, is going to be independent of another person if they got a headache or not. So these definitely are going to follow into the independent category. Now, do we have 2 categories of outcomes? Well, since we're recording yes if they got a headache or no if they didn't, this actually just has 2 categories of outcomes. So this right here is going to fall in the binomial situation. And then, of course, since we use Lipitor for every one of these experiments, every one of these patients, our probability of success is going to be the same in all trials, so we didn't change our drug or anything. So we are definitely going to say yes on that. Like if we had half of them use Lipitor and then the other half use like Zyrtec or something, some other type of drug, then you'd probably say no, the success is not the same. Success being the probability of getting a headache is not the same with the drug Lipitor as it is with Zyrtec or whatever. So it would change. But since we use Lipitor, it's the same in every trial. So this right here is yes about binomial experiment. Look at the part B. It's almost the exact same situation as the previous one. It says 863 subjects with Lipitor. But then we ask them the kind of open-ended question, how does your head feel? And you're going to see that, yes, this does have a fixed number of trials. Yes, they're all going to be independent, and we are using Lipitor, so the trial's success of, the probability of success, in this case, probability of having a headache, I guess, does remain the same in every trial. But what changes about this? Well, when we open-ended ask them that question, how does your head feel? They can answer a lot of different ways. Like they can say, oh, my head feels stuffy, or oh, my head feels congested, or lumpy, or I don't know, whatever they might say. Who knows what they might say. So this definitely is not going to be binomial because it doesn't have 2 categories of outcomes. Okay, it actually does not have a success and failure classification. It has lots of options. So we're going to say no, not binomial. And you can say because it has more than 2 categories of outcomes. Okay. Now, when you go to find binomial probabilities, okay, you can actually use technology to help you find binomial probabilities. As long as you know that, yes, the situation is binomial, you can actually use this, and your calculator has a formula saved inside that it's running. So if you do use on the homework, like help me solve this or review an example, sometimes they'll walk you through the complicated formula method. I will say just try to get used to using this calculator function because it'll do a lot of the heavy lifting of the formula for you. It's not a complicated formula, but it does have some weird things in it that you might not be used to seeing, like exponentials. And it has lots of powers, raising things to powers. But yeah, all you're going to need though for your calculator is when you go to it, you're going to have to put n in first, which is your number of trials. Then you have to put p, which is probability of success. And then last, you have to tell how many successes you actually want. So that can be any whole number that you want up to the max, up to the number of trials. Okay, and you'll see it on your calculator screen when you go to vars button, and then it's A under vars right there. Or sorry, second vars, and then it's A under that. Binom PDF is what we'll be using. Okay, so let's look at an example here below where it says, hey, let's assume we have a binomial distribution with a trial repeated n times. Use your calculator to find the probability of exactly 4 successes in 8 trials if the probability of success is 10%. So just kind of an easy way to get us started practicing using this formula, or using this calculator function right here. So we know we have 8 trials, so n is going to have to be 8, okay? And then we have probability of success, p, is 10%, so 0.10. And then x, how many successes we want exactly 4, so you want to put in 4 as that. Now on your calculator, you're going to want to put in under Binom PDF N8 P.10 and X4. Okay, and it'll appear on your screen after you hit calculate or enter. It'll appear like this right here. Okay, so let's go find this. On our calculator, we're going to hit second and then VARS. Scroll up to get to A, easier. But we see it on A option, Binom PDF. We want to put in our number of trials first. That's going to be 8 trials. Probability of success is 0.10. And 4, exactly 4 successes. And we're going to paste. And this right here will end up giving us our probability of success for this binomial experiment. 0.00, we'll do 4 decimal places. 46. Okay. And that's how you compute the binomial probabilities. Right there. Let's look at a problem down below. Multiple choice questions on an exam have 6 possible answers, so it has A, B, C, D, E, F. Let C represent getting a question right, and W represent getting a question wrong. Assume there are 3 questions on this exam. Answer the questions below. So we want to use first the multiplication rule to find the probability of getting the first one correct, second one wrong, and third one correct. So correct, wrong, correct. Okay. So when we want to find this probability, of course each one of these are independent. So the first question, since there are 6 possible answers, our denominator is going to be 6, and we want to get it correct. Well, there's 1 out of 6 possible ways to get that first question correct. Now, go into your second question. So we want to do our second question, right? We want to get it wrong. The middle question we want to get wrong. Well, that's going to end up being 6 total possible answers because it's A, B, C, D, E, F. And how many of those are wrong? Well, almost all of them are wrong. 5 of the 6 answers are wrong. Okay. Then last but not least, we have the last one being correct. That's going to be 1 out of 6 as well. So C, W, C right there. And this is just like something we would have done back in section 4.2 where we are multiplying these fractions together. So when we do this, 1/6 times 5/6 times 1/6, we end up getting 0.0231. You can actually make it into a fraction if you want to, hitting a math key, hit number 1, convert to fraction. If you want to see it as a fraction right there, 5/216, which ends up being 0.023. We'll do, 1. We'll do 4 decimal places for that. Okay. Next part right here says, find the probability of wrong, correct, correct, and correct, correct, wrong. So we want to find 2 other different ways to get 2 correct and 1 wrong. So just the other options. Okay. So let's do each of those on the side here. We have wrong, correct, correct, and probability of correct, correct, wrong. Okay, the only thing that really changes with both of these is the order that you multiply in. So you can see you're still multiplying the same 3 fractions right there. So what's going to happen here is you actually get the same number 3 times. 0231.0231. Okay. Now, it says combine these 3. So basically it's saying, like, combine these 3 different numbers right here to find the probability of getting exactly 2 questions correct. So we want to do probability of 2 correct exactly 2 correct. Well, what this is going to be in is 3 times 0.0231. And you can just do that on your calculator. 3 times 0.0231. You could actually go to more decimal places if you wanted to be more exact. So you could type in like 481,481. Go all the way if you needed to. But you're getting about 0694 roughly as your probability of exactly 2 correct. Now, this last part says verify first that this is a binomial distribution and use your calculator to check your answer from part B. Now, we can see there is a fixed number of trials because we only have 3 questions that we're looking at, so n is 3. Okay, and of course the probability of success is the same in each trial, so we have, the probability, let's say success is getting a question correct, right? So that's 1 out of 6. It's 1 out of 6 for every one of those different trials, each question. Okay, right there. And they are all independent of one another, so what you answer for one of them does not really dictate what happens on the others. But the thing you might be debating is, like, is this binomial? Well, since we're saying the classification is correct or wrong, so you get the question right or wrong, that's 2 possibilities of outcomes. This is binomial. So yes, it's binomial. So what we could do is, when we run binom PDF, if we wanted to, we could type in our number of trials as 3, our probability of success. Well, let's say getting 1 correct. Let's let getting 1 correct be our success. So 1 out of 6. And then X, how many successes do we want? We want 2 successes. Okay, when you run that on your calculator, let's see what you end up getting here. Second vars, go down to binom PDF, and let's put in that information that we need here for our scenario, and you'll see, very interesting, what you got. We get 0.0694, the exact same answer we got when we kind of did it the way of chapter 4, where we thought about every possible combination that we could use and then just, rearrange the letters. Well, now we don't have to worry about doing that because there's a lot of power in this Binomial PDF formula. This basically shows you kind of behind the scenes like what exactly is going on. It takes care of all of that heavy lifting, multiplication, thinking about all the possibilities situation for you. So it makes things a lot easier. Okay, so that basically just gives you an idea how the formula works and what you're going to be using it for. Now we want to use, of course, the calculator to make binomial probability distributions. Let's go down here to a problem where we have to do this, or where it will be helpful. Let's assume the fast food chain Wendy's has a 70% recognition rate around the world, and we're going to ask 5 people if they know about Wendy's. Construct a table for the probabilities of people that know Wendy's out of our sample of 5, and then answer the questions that follow. So on this problem right here, we're going to let X be, of course, the number that know Wendy's. And that's going to be the left side column. The right side column, of course, is going to be our probabilities, our P of X's. Now we want to make our trials go down from 0 to 5. So just make sure you have enough blanks for that. Hopefully that's enough. 0, 1, 2, 3, 4, 5. I need one more. Yeah, that should work. So we got 0, 1, 2, 3, 4, 5. And then once you get your chart beginning, we want to actually fill out the probability side as well. Now, how exactly are we going to generate the numbers that go here? Well, first, convince yourself this is a binomial probability right here, distribution, because the 2 options that you're going to have are people either know Wendy's or they don't know Wendy's. So this will end up being a binomial probability distribution. So you can actually use Binomial PDF for each of these. First, you want to put in your N right here. Well, we have 5 total trials. Probability of success, P. Well, the chance of them recognizing Wendy's is 70%. And then X. You want to put X as your last variable. Well, for that first row, our X will be 0. So we want to put in the NPX of 5.7 and 0 as our values for that first one. Now I'm going to show you a quick way that you can do this. Probably a couple ways. So we're going to put in this for this first one. And we'll get the value repeated out to the side. 0.00243. So 0.00243. Okay. Now think about what you need to change when you go down to the next line underneath, or the the one underneath. You're going to change what? Well, the only thing that changes is your X. So what you can do here, if you want to, is do second and enter on your calculator. It'll bring up what you just entered. Scroll to the left, change that 0 to 1. And now it gives you the second entry in your table. Okay. And then you can keep doing that for all the rows below, on and on till you complete the table. And I'll let you complete that, on your own. I'll do it to the side myself here. If you want to pause the video, feel free to. It'll take me a little bit to get all these generated in here. Okay, once you get your table filled out, once you keep going down through doing the same method, you can now answer the questions that follow. Find the probability of exactly 2 people knowing about Wendy's. Well, you want to look at your table where X equals 2. And we see that the answer will be 0.1323 on that one. Okay. What about 2 or fewer? The chance that 2 or fewer know about Wendy's. Well, on this one, what you want to do is take the probability of 2 or fewer, 1 or 0 knowing about Wendy's. And of course, the word "or" when you see probability means to add. So we want to add up the numbers 1323, 02835, and 00243. And when you add all those together, you'll end up getting the answer that you need right there. So when we add all those together, we can see we get 0.1631. One thing I want to show you, just kind of a detour here, but when you go to second and then vars on your calculator, I want to show you one thing just kind of below Binomial PDF. Do you see this Binomial CDF function right here? This is very similar, at least it has the same entries almost as Binomial PDF. It is a cumulative frequency distribution though. Okay, if you actually put in 0.5 and then 0.7, and then down here where you put X value, let's say we put in the value 2, this is going to actually add up 2 and everything below 2. So it'd be like 2, 0, and 1, or 2, 1, and 0. Okay, which is what we actually just did. So you can actually check using Binomial CDF if you wanted to this problem we just did right here, which is what we ended up getting. And then it says find the mean and standard deviation for the number of people who know about Wendy's. Now, the way we did mean and standard deviation in the previous problems was when we went to edit mode. We have 0 through 5 will be in this first column here, but in the second column we want our probabilities. I want to show you something real quick, so I'm gonna go ahead and enter in 0 through 5 in my first column. But in that second column where I want to put the probabilities, I'm going to show you something real quick. So I went ahead and cleared those out. But what I want to do now is generate all the values that are in this second column right here. I'm going to generate those and show you how you can actually just store those to list 2. So this might be quicker for some of these problems where you have to actually find the mean and standard deviation. So I'm going to go back to the home screen by hitting second and then quit. So I just went back to home screen. You can clear off everything that's on your calculator screen if you want to. Go to Binomial PDF, so second, vars, and then you want to scroll to A, wherever it's at, Binomial PDF. Now on this right here, put in your number of trials. We have 5 people that were asking about Wendy's. Put in 0.7. But where it says X value, leave that blank and go to paste. Now you only have 2 numbers. You have N and P. But if you hit enter on this, it actually will give you several values. Once you hit enter, just hit enter once, don't hit any other button. And then you can scroll left and right and see that all the values you have written down in that right column are actually on the screen displayed now. So that might be a quicker way to generate those values. And if you want to store those into a list, let me show you. Hit this store button on your calculator, STO, and then you can store it to whichever list you want by hitting second, and then I'm going to hit number 2 to store it to my list 2. And it just repeats it again, but now go into edit mode, stat, and then number 1 edit. You'll see, scroll down, all the values are there. And if you need to see them more clearly, it is a good idea to scroll on them if you have to put them in MyLabs Plus or some other kind of homework system. You want to scroll on them so you can maybe see all the decimal places you need. But now we have all the values stored in list 2. We can actually find the mean and standard deviation really easy using this feature. So now I can go out, do stat, go over to calculate, and then I can bring up on my calculator list 1, list 2, and my mean is going to be 3.5. So my mean will be 3.5 people knowing Wendy's. And then the standard deviation will be 1.0 if you do 1 decimal place people. Okay. And then it asks, is 0 a significantly low number of Wendy's? You could actually do your number line setup now, or you can even use probabilities if you wanted to. If you do the number line method, 3.5 is in the middle. When you go 2 standard deviations this way, you're just subtracting 2 from that, so 1.5. And adding 2, you'll get over here this way, 5.5. So this is where the usual amount of people knowing Wendy's are. And then significant, when you want to talk about significant, will be significant amounts of people knowing Wendy's would be in this range and this range over here. So you don't want to go in those ranges for, though, knowing about Wendy's. And I will say 0 people knowing about Wendy's is in this range over here. 0 people would be on the far left. So yes, 0 people knowing Wendy's is significantly low. That would definitely be an unusual amount of people to know, or I guess not know about Wendy's. 0 people knowing is significantly low. And that's how you do your binomial probabilities. Okay. Now, one other thing I want to mention is, mean and standard deviation. We found those just now using one of our stats. But for binomial, and that's the way you'll normally do it for probability distributions, is use list 1, list 2. However, for binomial distributions, okay, this only works for binomials. But you can actually use the formula for mean n times p, and that will give you the mean of your probability distribution. Now let's look at this right quick, right? So, we got the mean up here is 3.5. So let's say we take our calculator, the n is 5 and the p is 0.7. If you multiply 5 and 0.7, you end up getting 3.5. So the formula does indeed work. Just for binomials, though. It don't work for your everyday average, probability distribution. But then standard deviation, the way you're going to find it is use this formula. This is a quick way to do it. Square root of n times p times, and then you're going to multiply by the complement of p after that. So this is all underneath the square root too. So I do 1 minus p underneath. So let's show you how that works with this last problem right here. So when we do this on the calculator, we'll bring up the square root, and then we want to do 5 times p is 0.7 times, and then the complement of 0.7 is 0.3. But if you want to, you can just do parentheses 1 minus 0.7 right there. And then once you put all that in, you'll see we got 1.0246. Well, that's the exact same standard deviation we got in that previous problem as well, 1.0. So that's a quick way to do mean and standard deviation for binomials only. And where that might come into play is, let's say you have a final exam in a sociology class, has 100 questions. Ooh. There are 5 possible answers with one of those correct. Identify n and p. Well, n obviously is 100. And let's say p, let's let p be probability of question right. So probability of correct. Well, what's the probability of getting one of these questions right if it's multiple choice with 5 answers? Well, it's going to be 1 out of 5, okay? Or 0.2 if you want to make it a decimal. That might help too. 0.2. Okay. It says find the mean and the standard deviation for the number of questions correct. Well, this right here is binomial because, we have a fixed number of trials, 100. Each question is going to be independent of the previous questions before it. So that's satisfied. In the probability of success, since they all have 5 answers and one of them is right, all probability of success is the same in every trial. And the 2 options for your 2 possible outcomes is you either got it correct or you got it wrong. So 1 out of 2, there's 1 of 2 possibilities that could happen. So this is binomial. So we're going to say the mean, let's use that formula, because I don't want to have to generate a table with 100 values in my list 1. So we're going to do mean, that's n times p, which is 100 times 0.2 right there, which is just 20 questions right. And then your standard deviation, you can use your formula to find the standard deviation. Square root of n, so that's 100, p, 0.2, and then q, or 1 minus p, which will be 1 minus 0.2, which will be 0.8. So you can do 1 minus 0.2 if you want to, but it's just the complement of p. So here's what we got. Square root of and P. And then Q, sometimes they'll have in the homework Q. They use Q as a complement for P a lot of times. But 1 minus 0.2, which is 0.8. And we end up getting 4 when we take the square root of all of that. So 4 questions. So that's your mean, your standard deviation. And then it says, would it be significant for somebody to randomly guess and get 60 correct? Well, you can use your number line to figure out this one as well. Let's put our mean in the very middle. So we want to put our mean in the very middle here. Mean is 20. When you go 2 standard deviations to the left, you got to subtract 8 basically. You got to subtract 4 twice. So 16 and then 12. So that's the mean minus 2 standard deviations. And then when you go forward, 24, 28, that's the mean plus 2 standard deviations. So usually where people normally get questions right, this is where most people, if they're randomly guessing, would fall at. Between 12 and 28 questions correct. Okay, so we're going to say most people are in here if they're randomly guessing. Most of the randomly guessing people would fall in there. So anybody that falls out in this range and this range would be significant. Well, 60 questions is way over here. So yes, 60 is definitely significant. Very significant. So yes, 60 correct is very significant. So that might lead you to think that that person probably was not randomly guessing. They probably were eliminating some of the answers on some of the questions. So definitely suspicious. Okay, and that right there concludes all you need to know about binomial probabilities as far as this chapter 5 goes.